Now let's talk about cache. Cache is a bit like sugar. Sprinkle a bit of it on everything and everything just performs better. Just like sugar, putting a bit of sugar on anything will always make it taste better. Well, maybe not everything, but the point being, cache speeds up just about everything in the storage world. In fact, without cache, the last few decades in the storage world would have been agonizing. Put simply, disk is slow. Properly slow. We're talking thousands of times slower than CPU and RAM. And most of the time cache is RAM or DRAM based. But why, if disks are so slow and cache is so fast, why don't we just use cache all the time? Well, an old saying in the storage world, cache is cash, meaning that cache is expensive, it costs a lot of money, or a lot of cash, C-A-S-H, so we're forced to use it sparingly. Even though some large storage arrays may support a whopping 1 terabyte of cache, that's actually not always a lot, especially if the array's got around a petabyte of disk in it. It's all about the ratio of cache to disk. Now then, of course, flash drives are different to spinning disks, so often they don't need either as much cache as disk, or maybe sometimes no cache at all. For example, flash media is super fast at read workloads. Not as fast as cache, but amazingly fast compared to spinning disk. So maybe flash-based systems don't need as much cache. But in the spinning disk world, cache is vital. As an example, when a user or an application makes a read request to a storage array, if the data being read is already in cache, the response to that operation will be much faster than if the data isn't in cache and has to be fetched from spinning disk. Same goes for a write to disk. If that write can be acknowledged back to the host or application when the data hits cache, the response will be so much faster than if the data has to be written out to actual spinning disk. Much, much faster. So in the previous read and write examples, when an operation can be satisfied from cache without having to involve disk, we call it a cache hit. Whereas if it has to go to back-end disk, we call it a cache miss. Obviously, we want cache hits and not cache misses, because a cache hit means that we're satisfying all of our I/O from cache rather than having to go to slow disk. The point being, cache has a major impact on performance. And another important cache-related metric to watch out for is write pending. All storage arrays have watermarks in their cache memories that trigger different behaviors. Typically, a high cache write pending watermark will be around 70%, meaning that once 70% of cache is full or used, the system has reached its write pending threshold. And often, when this threshold is met, the system will go into some sort of emergency DStage mode, where it starts emptying cache as fast as possible. Emptying meaning destaging contents to disk, and this has a huge impact on system performance. And if it happens regularly, you need to investigate why. Maybe you don't have enough cache in your system, or maybe there's something not configured right in your environment. Whatever it is, it needs to be addressed. And one final point on cache, write-through mode. Cache write-through mode is where write operations are not signaled as complete until data is written to disk, spinning disk, or flash media if you've got a flash-based system. But if it's spinning disk-based, this mode literally canes performance and brings systems to their knees. Systems can be forced into write-through mode for a few reasons, but probably the two most common reasons are hitting the high write pending watermark and when cache DIMMs or cache cards fail. On the latter, where cache DIMMs or cache cards fail, most caches are mirrored, where data is written to both sides of the mirror for redundancy purposes. But if one side of the mirror breaks or fails, then data in cache will be lost if the other side of the mirror fails. So in order to not lose data, the array will stop acknowledging operations when the data hits cache, and will start waiting until data is persisted to back-end disk before it acknowledges the writes. This is write-through mode, and you want to avoid it at all costs. And that's cache, mega important in disk-based systems.